When doctors perform cancer surgery, they often remove so much tissue that it leaves serious indentations. And when the surgery is done on the face, it can alter a person's appearance.
Health specialist Denise Dador joins us now to explain how one doctor has developed a procedure to restore what was taken by the cancer.
I haven't seen anything like this, so take a look at this. The science of stem cells can help doctors restore weak hearts and help heal joints. Now a local doctor is using adult stem cells to reconstruct tissue, nerves, and bone destroyed by cancer and the cancer treatment. It gave hope to one man who was told repeatedly nothing could be done to restore his face.
Take a good look at Herschel McCallian's face. You'd never know he used to have a gaping hole on the right side.
I was very sad. I was very angry that the doctors previously, they did the surgery, even though it was the right things to do.
He had a salivary gland cancer that required the removal of part of his jaw.
I had a tremendous amount of pain in my jaw area because of the nerves. They were basically exposed. I looked for a reconstruction surgeon. Most doctors, they did not want to touch me.
That is until he met cosmetic surgeon Dr. Nathan Newman. He pioneered a new treatment called the stem cell lift. He removes fat from the patient and harvests one of the body's most precious resource, adult stem cells. He then doubles and triples the concentration of stem cells before injecting.
The stem cells is what brings in the new blood vessels, rebuilds the structures, maintains the volume by replacing the fat cells that die off.
Not only can the fat and stem cells be used for cosmetic reasons, Dr. Newman says the stem cells are so smart they can also break up scarring caused by the cancer treatment and rebuild and reconstruct surrounding tissues.
We take these fat cells that are enriched with stem cells and put them next to bone. I can actually grow bone and make that bone stronger and bigger.
Dr. Newman says there's no risk of rejection because you're using your own fat and stem cells. It took about 2 years and about 24 injections. Herschel says nobody can even tell he ever had a dent in his jaw, and the nerves and tissues appeared to have healed.
He has given me my face back, he has given me my confidence back, he has given me my hope back.
For most of us, these bizarre, otherworldly shapes are strangely beautiful. But the world's best aging researchers see something entirely different. They see the answer to possibly the most important and complex question of all time. Dr. Sinclair, as I look here, I'm seeing very cute little colored cubes.
Well, these little cubes are actually the protein in our bodies that we believe controls the aging process.
If he is right, Dr. David Sinclair has found one of the genetic keys that will reset our biological clocks.
I think we've passed a turning point in our understanding of the aging process.
How did he discover these proteins? This looks like a barcode, but it's really a map of our genome, the blueprint for human life stored in every cell in our bodies. A few of these genes play a key role in the speed at which our cells age. Dr. Sinclair randomly tested tens of thousands of cells, searching for the chemical that would activate those genes.
We found them by accident. We stumbled upon this molecule from red wine. And when I looked on the computer, what is this resveratrol, and found that it was in red wine, I almost fell off my chair. Because, of course, we all have heard that red wine is good for you.
Just so happens I have red wine.
To your health.
How much of this would I have to drink to really make a difference?
Well, our experiments tell us probably about 1,000 bottles a day.
So that was not the solution. Dr. Sinclair then went back to the lab and found a way to make resveratrol 1,000 times more potent. So what does it do in the body?
Well, what we have discovered is that resveratrol works on a gene which is called SIRT1, and this is a gene that controls the aging process. Resveratrol seeks out that gene and switches it on.
And with that gene activated in the mouse on the right by a high dose of resveratrol, she quickly turned into a mini Olympian, running twice as far as the untreated mouse on the left.
And they were eating a high-fat diet, a fatty diet, and they lived just as long as a lean, healthy mouse, which means that they didn't get heart disease, cancer, even osteoporosis, and they lived 30% longer.
Can you do this in humans?
They're the same exact gene. And we think that resveratrol could have similar benefits in people.
Realizing the blockbuster potential for his new pill, Sinclair teamed up with biotech entrepreneur Chris Westphal, together raising more than $100 million for further research.
And we think that we can increase healthy lifespan. So if you're in your 80s, you'll be behaving as if you were in your 50s.
In the first human trial, a form of resveratrol successfully treated type 2 diabetes, one of the major diseases of aging.
If everything goes very well, we will seek regulatory approval from the FDA in the next 5 years.
I think a lot of people will say you're raising expectations. This can't possibly happen.
My answer to that is, I agree, but it's true. What else can I say? Aging is really a set of diseases, and if we slow them down and cure them, people will live longer, healthier lives.
And you're talking especially now about diabetes and Alzheimer's?
So the major killers of Western society are exactly the diseases that should be able to be treated with the drugs we're developing.
Well, you know what, Doctor?
Cheers.
The future.
瑞典卡罗林斯卡医学院5号宣布，将2009年诺贝尔生理学或医学奖授予美国科学家伊丽莎白·布莱克本、卡罗尔·格雷德和杰克·绍斯塔克，表彰他们发现端粒和端粒酶是如何保护染色体的。
端粒是细胞染色体末端的一种呈条状的物质，可以维持染色体的稳定性和完整性。在不同的细胞中，它的长度不同，端粒的长度决定细胞分裂的次数，控制着细胞衰老死亡的过程，进而决定人的寿命长短。在新细胞中，细胞每分裂一次，端粒就缩短一次。当端粒不能再缩短时，细胞就无法继续分裂而死亡。端粒也被科学家们称为生命时钟。正常情况下，细胞平均可分裂50次左右，分裂的周期大约是2.4年。但由于环境污染、不良生活方式以及自身代谢产生的自由基及药物的毒副作用，端粒加速老化，导致提前缩短，缩短到只剩下一个残端，失去了再分裂的能力，导致细胞提前衰老死亡。怎样让端粒的长度不提前缩短，甚至延长，让细胞完全分裂50次，甚至更多次，成为科学家面前的重大课题。进一步研究发现，端粒的长度是由细胞中的一种酶决定的，它就是端粒酶。正常的人体细胞检测不到端粒酶，如果细胞的端粒酶活性因为某些原因被激活，它就可以修复缩短的端粒，可以让端粒不会因为细胞分裂而损耗，使细胞分裂的次数增加，生命得以延长。2006至2008年，《细胞》《科学》《自然》等权威杂志先后发表论文指出，端粒酶能够以某种方式被激活，进而修复延长端粒，并抑制癌细胞增殖，使机体年轻细胞和衰老细胞维持动态平衡。这些发现标志着人类破解了生老病死的密码，获悉了慢性疾病产生发展的根源，让人类看到了活到120岁甚至长生不老的曙光。